Does this happen to you? Having to sort out your algorithms with no disregard for humanity? Have you ever wanted a better solution than this? But first, we need to meet the team behind our product. Here's Jonah, our team designer. And here's a random bystander. Here's Vince, our manager. And here's our cameraman, Clyde. Say hello, Clyde. And here's our gunman, Lance, and his hostage, Hosea. Come on, bro! And yours truly, Jonas. We introduce to you our greatest product ever invented, and that is the Quick Sorter. Here we have the Quick Sorter, one of the best algorithms in the world, and there's no money that can really pay well than this sorting algorithm. It's so efficient at its job that you won't really want anything else. However, there comes a cost, and it's really simple. You need a human to do it. Here we have the Quick Sorter in action. First, it finds a pivot, and then it sorts. And then it finds a pivot, and then it sorts. And then it finds a pivot, and then it sorts. That's basically the algorithm. It's just a recursive algorithm. Here's a more in-depth demonstration of what quick sorting is. First, you must find a pivot, and then rearrange it from left being the smallest and right being the largest. So here we have 1 being the smallest, and make sure you arrange it in order. And once everything is done, you must then recursively find a new pivot that then sorts out from the left, then to the right. And then we must find a new pivot as this pass is done, that being 4, and then we arrange according to the already arranged order, and somehow using this algorithm everything is already arranged. But you might be really confused. What is pivoting? Well, let me explain to you the pivoting technology. It's really simple. The pivoting is actually really different. It works well with other algorithms. Let's say, for example, merging algorithm or even insertion algorithm. It really depends on what you do with it because it really complements with other algorithms. But as an algorithm as its own, what you really need to be focusing on is the pivoting. There are many cases on how you might choose the pivot. You might be choosing this first, this middle, or this last. In this case, you might really need to choose the middle element as your pivot. See? Then, what you need to do next is to sort out every algorithm less than the pivot and greater than the pivot in each of their respective sides. For example, what is less than 15? That would be 12, 5, 10, and 2. So let's put here 12, 5, 10, 2, 15. And what's greater than 15? That would be 50 and 20. Let's make sure they're really in order. And that's how our hostages work. Now, on to the next iteration. So, what pivot should we choose next? Maybe let's choose the middle again. The pivot. Then we now write the next iteration, biggest to the largest. So in this case, this will be the smallest. 2, 5, 12, 10, 15, 50, and then 20 again. And we need to choose the pivot once more. This one, 10. Then 2, 5, 10, 12, 15, 50, and 20. Then let's choose another pivot. Now, what would be a good pivot? Why don't we try 50? Then let's write the next iteration. 2, 5, 10, 12, 15, then 20, then 50. You might have noticed this is the sorted array. But what really matters the most is how you might select the pivot. And whoever your hostage is, you must teach him or teach her, or in the modern society now, to choose the right pivot. So let's reiterate. Choose the right pivot for your quick sorting algorithm. And that I add how it works. And here we have the algorithm analysis of this, quicksort algorithm. So you might have noticed that we actually call the algorithm back then. It's a recursive algorithm, and it's supposed to be the best case scenario of the quicksort algorithm, or any recursive algorithm would be n log n, because this would be the processing time, the speed, or the performance of the algorithm. However, if it can't really sort anything else, it would be n squared, which is this, which again you don't really want. But as an advice, if you want to use quicksort, it would be, let's say you would find a complementary sorting algorithms, for example, merging, insertion, selection, any algorithms that would work. And to reiterate, we have n log n as our best case, n squared as our worst, and 1 if you found the right hostage. Wink. But you might be asking yourself, what if I can't find someone else to do my dirty work for sorting? Well, there's an alternative, and that is coding. So assuming you know Java, you must first create a class for quicksort and then implement for class, two of which are utility class responsible for returning string and printing out the results of your sort. Here, there's the printing out way of doing things. And here, the returning of string, a variant of this method here. And now we have the two most important class, and that is the quicksorting class, which is a recursive method, and the partition class responsible for switching and finding a good pivot index. And it's really simple. It just compares other elements if it's lesser than or greater than the pivot, and if it is, then it just swaps the element in style. So here it returns the p index, which then does the dirty work for this method of other recursive methods. And that would be the end of your code. So assuming you have implemented all the 4 methods correctly, then you should have a proper sort, which is this. See, it has sorted it correctly from smallest to the biggest, and it should have a time efficiency of, let's say, it would be pretty decent to compare it with other sorting algorithms like merge and double sort. So it's really efficient depending on where you might want to go with the kind of array you're working with, and it might be not really efficient if you have the worst kind of arrays possible, or a worst kind of array known to humanity. Again, it really depends on the situation, either for the best case or for the worst case. And that we end this infomercial for this product. And if you want to buy this product yourself, you can contact us, especially our Gunman Lance. They will do the dirty work for you. So again, please follow the number below to buy our product. Guys, right,